Hope I'm audible to each and everyone. Just to let me know. My dear students, this is your Baba HSP in front of you. Everyone, just to let me know. Can you hear me? Can you see me? I want to see fire in the chat section if I'm audible and visible to each and every one of you. Everyone, just to let me know. Today I'm going to start with GOC from the scratch. But I want to see some fire or green hearts in the chat section if I'm properly audible and visible to all of you. Just let me see. Show me some fire if everything is perfect, kids. Yeah, now I can see fire in the chat section. The chat section is full of fire, green hearts. That's really awesome. Let me see some chats, then I will tell you what I'm going to do. My dear students, yeah. So chat is full of fire as well as green hearts. Now, my dear students, wow, that's really fantastic. That's really fantastic. Now, let me tell you, my dear students. First of all, Suswagatam, Abhivadanam to each and everyone. To each and every one of you, Suswagatam, Abhivadanam. And this is going to be the first class of this very awesome new session from Baba HSP. Myself, Harendra Singh Parihar. I will give you my introduction later on, my dear students. Today, this is the time to teach, to tell you each and everything. If you want to know, if you're new to this channel, you can understand one thing very clear, that you are going to get quality content. Mark my words, you will get quality content, and that too, starting from the zero level. Just remember this point, categorically I am telling you this point, my dear students. GOC, which holds a hell lot of weightage, I'm going to tell you each and everything from the scratch. Are you ready? Everyone, just do let me know. If you want to get command on GOC, that is organic chemistry, that you should know, first of all, the chemical bonding. GOC is the backbone of organic chemistry and chemical bonding is the backbone of GOC. And I'm not going to tell you each and everything about chemical bonding, my dear students. I will let you know only. Today's focus will be starting with alkane, alkene, alkyne. Alkane's hybridization is sp3. Alkene is sp2. And alkyne is sp. How and from where you are going to get this type of hybridization, which orbitals, and what are the things which are responsible for making all these things, I will tell you each and everything in detail. So I want to see the Josh in the chat section. Let me see how many of you are present. And yes, you have to mark your attendance in the form of, yes, the likes. You know, whenever we are on YT, automatically it comes from the internal core of heart that, yes, hit the like button. Everyone, hit the like button and mark your attendance, my dear friends. Likes are very, very less. Why it's like this, kids? If you want each and everything in detail, then hit the like button, my dear friends. Now, let me fix it. Now, let me start. Sim, GOC, that is Journal Organic Chemistry. The full form of GOC is Journal Organic Chemistry. Journal organic, zoom, organic chemistry, journal organic chemistry, my dear students. So in the journal organic chemistry, see, I will start with methane. The carbon in methane, or if I talk about ethane, the second member, homologous member, all the carbons which are attached with single bond, they are known as sp3 hybridized. sp3 hybridized, sp3 hybridized. If I talk about percentage of S character, then it will come out to be 25%. Now, what is the meaning of S character? How we are getting sp3 hybridized? Everyone, I will let you know from the beginning. So this is the carbon. We should understand carbon, and carbon's atomic number is how much, my dear students? Carbon's atomic number is 6. Let's start from very beginning. Above principle, Pauli's exclusion principle, and Hund's rule. Above principle says that filling of the electrons will take place starting from the lowest level and moving towards highest energy level. Above means building up. Above is not a scientist. So, Pauli says that an orbital can occupy maximum of 2 electrons, and that too with opposite spins. And Hund says, don't make a crowd. Pairing of the electrons will not take place unless and until all the orbitals are filled with single parallel spin electrons. Right, kids? So, in the light of above, Pauli and Hund's, I am writing electronic configuration, that is 1s2, 2s2, 2p6 or 2p how much? These are 6, 2 to 4 and 2, 6. Is this point clear to each and everyone? I have started from the very beginning, my dear students. Now see, outermost orbit is 2s2. So I will write 2s2, 2 electrons, and 2p2. Orbitals are 3 in p subshell, but filled are 2. This is the ground state configuration. Ground state. Now, my dear students, if you apply some energy, then one electron will shift from this orbital to this orbital, because negative charge, their repulsion is there. To minimize that repulsion, one electron will shift from this orbital to that orbital, although that orbital right now it is having a little bit more energy, because energy level is like this. Everyone, are you getting my point? Now, it will look like 1 and 3 electrons. My dear students, just see, 1 electron has transferred. Now this is 2s1 and 2p3. Till now it's clear, this is first excited state. Now, my dear students, I will move ahead, but let me check it out whether you are able to hear me. Am I perfectly audible? Because right now I am not having clip. So let me make sure that Baba is audible and visible to all of you perfectly, because this is the first class, so I have to make sure. So let me know in the chat section that you can hear me, you can see me. Sahana is there. Welcome, Sahana. Welcome to each and every one of you kids. Manasha, Ya, Aryan, Hami, everyone do let me know. I'm at the chat section that my voice is clear. I'm perfectly audible and visible to all of you, my dear friends. Just to let me know, everyone. Yes, 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 yes. Okay. Now this thing is very clear. Now see kids, everyone just see. If I say that this was S and this is P, S and P subshell is further divided in 3 parts. This is having 1 electron and that is having 3 electrons. Now my dear students, just see to it, everyone. S is spherical, non-directional, that distribution electron is continuous everywhere. But P, if I draw P orbital, then let me take 3 axes. Just see to it, my dear students. X-axis, Y-axis and Z-axis, just see to it. If I say this is 2px, this is 2py and this is 2pz, then the shape of p orbitals is dumbbell shaped. So I would like to say p orbitals are like elongated one and lengthy one, like pineapple. You can say pineapple. These p orbitals, let me shade them like pineapple. Okay. If you're not able to understand the hybridization, then let me mark them like pineapple. They are like pineapple. Okay, let us consider them to be the pineapple. Let's call them to be pineapple. And with S, what do you say? Tell me any name of fruit with S which is being spherical. Everyone, do let me know the name of any fruit which is starting with S. Let me see in the chat section. Any fruit's name starting with S. Everyone, do let me know. P for pineapple. If Baba is saying P for pineapple, then I want to see in the chat section S for any fruit's name. Everyone, just any fruit's name starting with S. Kids, fast. Okay, no answer is coming from your side. So let me tell you from my side only. If you're not able to tell me name of fruit with starting with S, then let me say S is what? S is what? Any fruit's name is starting with S. So let's say anyone in the chat section, strawberry, sapota. Yeah, sapota, chiku is sapota. So let me call it sapota. That is being chiku. Now my dear friends, the energy is like this. The energy right now is like this. P is having more energy and sapota. You know that pineapple juice is having a little bit more energy than sapota. You know that, but only a bit more energy. If I say it is having a little bit more energy, my dear students, little bit more energy. So energy. Now, if I mix 1 sapota and 3 pineapples, let's say there are few, you can say 4 people are there. Everyone wants to have 1 glass of juice. Now the one who is making juice, he has taken 1 sapota, circular spherical sapota, and he took 3 pineapples. Now he is going to prepare 4 glass juice, that he is mixing 1 sapota and 3 pineapples. So what do you think? After mixing 1 sapota and 3 pineapples, you are going to have 4 glasses juice. The juice will have more taste of what? The sapota or the pineapple? Do let me know in the chat section. That juice, each one is going to have juice. That juice will have more taste of sapota or the pineapple. I want to see the answer in the chat section. Everyone, do let me know in the chat section. Kids, hey, fast, do let me know. The juice will have which fraction, which percentage more, the sapota or the pineapple, kids? Pineapple. Very good. Very good. This pineapple, because this juice is made up of 3 parts of this pineapple, my dear students, 3 parts of this pineapple. 3 parts of this pineapple. Everyone just see 3 parts of this pineapple and only 1 part of sapota. 1 part of sapota. Kids, is it clear? If this much is clear, I can teach you each and everything, because I am starting from the scratch. So I have to tell you each and everything from the beginning, from the 0 level. Please don't mind. Don't say like that. How much time you are taking, sir? Please don't say that, right? Now see, 1 part of sapota and 3 are part of pineapple. After mixing, once I have mixed, this mixing is known as hybridized form, hybridization. This mixing of 1 sapota, 3 pineapple means 1 orbital from the S subshell and 3 orbitals from the P subshell is known as hybridization. Now 4 orbitals got mixed. 4 orbitals got mixed, and now my dear students, just see to it. After mixing 1, 2, 3 and 4 glass juices I am having, and now my dear students, can you identify which one is sapota and which one is pineapple from that glass? After mixing 3 pineapples and 1 sapota, is there anyone who can take it out from that juice, the sapota portion separate and the pineapple portion separate? Is there anyone who can take out, who can separate out? Now I want to have sapota separated. Separately I want to drink sapota and pineapple separate. Is it possible? Mixing is easy, but to separate it out, it's not that easy. Are you agreed with me? Now, what will you say? This glass juice is sapota or pineapple or mixed? This is sapota and pineapple. Sapota and pineapple. Sapota and pineapple. Sapota and pineapple. These are the 4. Yes, 4 glasses filled with the juice. 4 glasses filled with juice. Now I will say they are having pineapple portion as well as sapota portion. Are you getting my point, kids? Are you getting my point? They will look like this, and each glass will known as sapota, pineapple. 1 part of sapota, 3 parts of pineapple. You can say 25%. Each glass, if I say each glass is having juice, and that juice will be known as made up of sapota, 3 parts of sapota, and no, sorry, one part of sapota and 3 parts of pineapple. Am I right, kids? Right? Am I right, kids? Am I making sense? Just do let me know that this juice is made up of 3 parts of pineapple and 1 part of sapota. So I will say that percentage of pineapple in this 1 glass juice, pineapple. What is pineapple? Pineapple. The pineapple part is, percentage of pineapple is 75%, and sapota portion is how much? Sapota portion is, percentage of sapota is how much? Percentage of S is just 25%. Are you able to understand this much, kids? Do let me know first. Is the glass clear to you? If yes, show me some fire, show me some hearts. This is first class, and I want to see that whatever I'm going to tell you is visible to all of your note. Let me draw this on another page and just try to understand what Baba is going to tell you, that this is 1 glass. Like this 1 glass, I'll be having 4 glasses. See, right now I'm making just 1 glass. This 1 glass, it is having how much portion of sapota? 25%. How much portion of pineapple? 75% portion of pineapple and 25% of this. Now, if I say, kids, that I'm having 4 glasses, same type of 4 glasses, all the 4 glasses, they are having same thing. So I will say its name is SP3. Its name is SP3, kids. SP3. Its name is also SP3. Its name is also SP3. Its name is also SP3. And the percentage of S is how much? 25%. And percentage of P is how much? 75%. So I'm having 4 orbitals, and all 4 orbitals are identical. All 4 orbitals are identical. And these 4 glasses, let me draw in the form of orbitals. Right now they are glasses. I will draw in the form of orbital. But remember that, my dear friends, the S will have a little bit of P character and P will have a little bit of S character. What I am trying to tell you, let's see. Let's see what Baba is going to tell you, kids. Just see to it. Just see to it. See, kids, what I'm trying to tell you. Suppose if I'm having one S means this is S. Let me say S is any name S, spherical type S, Shanu, 1 Shanu. And I'm having 3 Champa, 3 Champa. This is 1 Champa, this is another 1 Champa, and this is another 1 Champa. If I draw Champa is like this, Champa is like this. Slim and trim. This is slim and trim, elongate one, and this is round Shanu. Now, if it is possible that 3 Champa, 1 Shanu, if I am having such type of furnace, if I add all these 4 persons in that furnace, by chance, it's not possible. I know that everyone we can understand. This is fatty. The Shanu is fatty, and these are slim and trim. Slim and trim. Now, if it is possible that we are getting from that furnace 4 persons, then the 4 persons, they will come out like this. See, they will come out like this. Champa will get a little bit fatty and Shanu will get a little bit slim and trim. That 4 persons I will get same type of 4 persons, same equal 4 persons. Are you getting my point, kids? Everyone will be now known as SP3. All these 4 persons now identical. This Shanu will get some P character and this Champa will get some S character. Now everyone is having SP3. Kids, from my side, I am trying my level best. I don't know how much you are able to understand. Now I am going to draw the orbitals. First of all, everyone do let me know you are able to understand a bit better. I want to see your comments, kids. Then only I will keep on teaching like this. If you are able to understand, kids, your understanding is my prime priority. I want to see that everyone is able to understand or not. My dear students, do let me know. Show me some fire in the chat section if you are able to understand. Because this is the only communication level from which we can understand that everyone. Saucy is there, Sahana is there, Green Hearts, Kiran nahi samjhe. Okay, Kiran nahi samjhe. Okay, Sahana is able to understand. Okay, now let me tell you. Don't worry. Let me tell you in another way. Just see, kids. Let me tell you in another way. Just try to understand. Those who are unable to understand, let me tell you in another way. Just see, kids. See, kids, see. This is, I'm having s orbital. Just see to it. I'm having s orbital. It's like this. This is s orbital. Okay. Now I'm having 3 p orbitals, 1 p orbital like this, 1 p orbital like this, 1 p orbital like this, x, y, and z. This is 2s. This is 2s. This is 2px. This is 2py. This is 2pz. All these x's are imaginary. If I combine all these 4, then how many orbitals I will get? If I add this, this, then I will get 4 orbitals. Just see to it. They will look like 1 orbital, see, and 1 lobe of the orbital becomes smaller. So this is bigger one. You can say this is bigger one. 1 lobe will become smaller. Second orbital, third orbital, fourth orbital. Now all these 4 orbitals, they are having one electron, one electron, one electron, one electron, one electron. So everyone's name will be known as what? sp3, 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 sp3. Now is it clear? Right now I am having 1, 2, 3, 4. 4 sp3 hybridized equivalent orbitals. Right now carbon is having 4 electrons in the valence shell, 2, 3, 4. Now carbon is in need of 4 more electrons. Now is it clear, kids? Now is it clear? Do let me know. Till now is it clear? Now see, this I have already drawn 1 sp3 orbital, 1 more sp3 orbital. The second orbital, the smaller one, you can skip, no need to show. And these are 4 sp3 orbitals with 1 electron in each. sp3 hybridized orbitals, equivalent energy. Now let me show you it over here also. It's like this, 4 sp3 hybridized orbitals, 1, 2, 3, and 4. All they are having 4 electrons like this, 1, 2, 3, 4, right? Now they will combine with 4 hydrogens like this. See to it. 4 hydrogen. 1 hydrogen will come with opposite spin electron. 1 more hydrogen will come with opposite. 1 more hydrogen will come with opposite spin electron. So these are 4 sigma bonds. Let me try to draw the sigma bonds. This bonding, this overlapping is known as sigma bond. Head-on overlapping. The one car is coming from this S car is coming and this P car is coming and there is clash. Accident. There is accident. So this accident, head-on overlapping, is known as head-on overlapping is known as what? Overlapping is known as sigma bond. Now this sigma bond is in between which orbitals? Just see, its name is sp3 and its name is S. So I will say carbon to hydrogen sp3 to S sigma bond. So how many sigma bonds are there, such type of sigma bonds? 1, 2, 3 and 4. There are 4 sp3 to S sigma covalent bonds. Now these 4 are orbitals. This is the orbital form, molecular orbital theory, and this is valence bond theory. I can show over here, this is hydrogen with 1 electron, this is hydrogen with 1 electron, this is another hydrogen with 1 electron, this is another hydrogen with 1 electron. So the overlapping you can see, kids, you can see this is the overlapping. Is it visible to all of you, kids? Is it visible to all of you? These are 4 this is MOT form, this is valence bond. Now how many of you are able to understand? Do let me know in the chat section so that I can move ahead. If everyone you got it, I want to see some fire, green hearts in the chat section, and smash the like button also, my dear friends. I want to see more likes. If you are able to understand, then I will tell you ethane. Fast, fast, kids, fast. Everyone, do let me know. Kids, this is the first class. Always show some fire, green hearts in the chat section if you are really able to understand. If everything is perfect. No, fantastic. I can see that everything is clear. Now see, if I draw for ethane, just see for ethane. Ethane is like this, CH3. CH3. How many carbons are there, kids? 2 carbons are there. Now try to understand. This is sp3. This is sp3. Now how will you see that? What does it mean, sp3 and sp3? Just see. I've told you this was the carbon. This is another carbon. These are the 2 carbons. Now this carbon is having 4 sp3 hybridized orbital. Just see. Everyone just see 4. Now this carbon is also having 4 sp3 hybridized orbitals. 1, 2, 3, 4. What designation should I give? See, 1, 2, 3, 4 electrons. This carbon is also having 4 electrons. Just see to it. 1, 2, 3, 4. Now this overlapping, this area I would like to say it's head-on overlapping. So head-on overlapping in between what? In between, first of all, let me give the designation, kids. This is sp3. This is also sp3. This is also sp3. This is also sp3. That is also sp3. 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 These are the orbitals. So this is head-on overlapping in between carbon to carbon sp3 to sp3 sigma bond. This bond's name is carbon to carbon sp3 to sp3 sigma bond. But if I want to say that this overlapping is in between what? sp3 of carbon and s of hydrogen. So carbon to hydrogen sp3 to s sigma bond. Now total sigma bonds are how many sigma bonds? Can you see, kids? Answer me in the chat section. How many sigma bonds you are able to see? Just to let me know, my dear students. Now you can see total 7 sigma bonds. Out of these 7 sigma bonds, 2 types of sigma bonds are there. One sigma bond is carbon to carbon sp3 to sp3, and 6 are 6 sigma bonds are carbon to hydrogen, sp3 to s sigma bond. Agreed? Agreed? Everyone agreed? If yes, show me some fire in the chat section. Let me check it out whether everyone is able to understand or not, my dear friends. This, your Baba is teaching you each and everything from the scratch. And I have got right to ask you. Omar, Adnan, very good. Sahana, very good. Samaili, Mishram, agreed. My dear friends, I want to see everyone whether you are able to understand or not each and everything. Wow, that's really awesome. That's making sense that everyone is able to understand. Wow, that's really awesome. Now, after this, I will tell you something else. But before that, let me give you one more thing, that you could have find out this thing in this way also, that is known as steric number. Steric number, my dear friends, what's that? What is steric number? That is number of sigma bonds plus number of lone pairs. And which lone pairs we have to see? The localized one. Localized lone pairs. So as I have told you that we have gone through CH4. I have written CH4 like this. So how many sigma bonds can you see, kids? That carbon 1 sigma, 2, 3, 4 sigma, and carbons, all the electrons has been neutralized. So steric number is coming out 4 plus 0, and 4 means sp3. S, that is always 1, and p3, the sum is coming out 4. Now my dear friends, after telling you sp3 hybridization, I'm going to deal with sp2. Are you ready for sp2 hybridization? Everyone just see sp2. If I talk about ethene, this is being your ethene, kids, and you can see very clearly that 1 sigma, 2 sigma and 3 sigma, 1 is pi. Now most of the students, they are always asking, sir, our upper one is pi or the lower one is pi. My dear students, you can say either one. One is sigma, another one is pi. In between two atoms, if 2 bonds are there, out of these 2 bonds, one is being sigma and another one is being pi. Okay, everyone, now see, we can also say that if carbon is attached to double bonded carbon, doubly bonded carbon or double bonded carbon is sp2 hybridized. You can say like this, or you can say the steric number of this carbon. Steric number of this carbon is coming out how much? You can see 3 sigma bonds. 3 sigma bonds plus 0 lone pair. This is coming out 3. So 3 means S1 and P2, sp2. Now one question arises over here. Sir, pi bond is having any role in hybridization or not? Remember that pi bond has nothing to do with hybridization. You can see it from here that pi bond has no role in hybridization. Pi, it's like this, pi bond will not play any role in hybridization. Now, how to see the molecular orbital theory for the hybridization? How to say what has happened that one p orbital is not taking part in hybridization? That is the $1 million question. Are you getting my point, kids? Should I explain? Is everyone ready for that? Just see. As I have told you, this is your carbon, atomic number 6, 1s2, 2s2, 2p2. So this is the outermost. So I will say 2s2, 2p2 like this. Just see to it, kids. I have divided it into 3 parts. Now I am having electrons like this. 1, 2, 3. This is the ground state configuration. Ground state. Now I have provided energy. After providing energy, 1 electron will, 2s2, 2 electrons. 1 electron will shift from here to there to have parallel spin. Now what will happen, kids? See to it. After providing energy, they will look like this. 1 electron will get shifted towards that side. 1, 2, 3, 4. This is excited state. Excited means we have provided some energy. Now, there are 4 persons. You can consider 4 persons. Now they are going to form the group. But while forming the group, one is saying, I don't want to be the part of your group. I have my own choice. Your business is your business. That's none of my business. So one p orbital will show its attitude. Now it is in attitude and saying, I'm not going to be the part of your group. I will remain away. I will remain what? Away. I don't want to be the part of your group. You can form the groupism. You can form the group. So now these people, they are forming group. Just see, these people are forming group. And that orbital is not going to be the part of group. Now 1 from S and 2 from P, they are going to form the group, and the group will look like this. See to it, kids. Now you can see very clearly, kids, how many orbitals they are forming the group. 1s, 2p, and 1p is away. That is not the part of group. That is away over here. Now you can say, right now we are having a juice of 1 sapota and 2 pineapples. 1 from sapota and 2 from pineapple. 1 from s orbital, 2 from p orbital. So we will say this is sp2, this is sp2, this is sp2, and this is pure p orbital, pure pineapple, pure p orbital. Now if any person is drinking this juice, he will have or she will have taste of 1 sapota and 2 pineapples, 1 sapota, 2 pineapple, 1 sapota and 2 pineapple. And if anyone is enjoying this juice, he will have pure pineapple, 100% pineapple. Are you getting my point? Now we are having in total 3 equivalent orbitals, 3 sp2 hybridized equivalent orbitals. Now if I show this on carbon, how it will look like, just see it over here. This is carbon, 1 sp2 orbital, 1 sp2 orbital, another 1 sp2 orbital, 3 sp2 hybridized orbitals. They are looking like this. Just see to it. Or if I color them, they will look like this. sp2, sp2, sp2. Now you will ask, sir, what has happened to the third one, pure p orbital? Now pure p orbital will be slim and trim because it has not hybridized So it will look like this. This is pure p orbital which is lying above the plane, vertical or perpendicular you can say, or it is lying 90 degree to the plane of paper. And why two lobes are there? Because it has not hybridized. Whenever there is hybridization, one lobe becomes smaller. Now my dear students, try to understand, this is only one orbital. It is having two lobes. Which orbital is this? This one. This pure p orbital is this. This is just, I will say, it is pure p orbital. Pure p. There are two lobes. One lobe, second lobe. One lobe, second lobe. These two lobes are making one pure p orbital, and these are sp2 hybridized one. This is sp2 hybridized. This is sp2 hybridized, and this is sp2 hybridized, and this is one lobe. Can you understand, kids? Can you understand these three orbitals? Now I will show you the bonding on the next page, but till now, if it is everything is clear, show me in the chat section that yes, till now everything is clear. Then I will show you the how the carbon and carbon, they are going to form a bond. Let me see in the chat section. One boy is writing, voice is not clear. I want to see from others. Am I audible, perfectly audible? Kids? Okay. Now see, now is it okay, Sahana? Now is it okay? Now is it okay? Now the voice is clear or not, kids? Do let me know. Everyone do let me know. I want to see now. Okay. So I'm going to tell you something more, and let me form the bond. Yeah, I will tell you why it is not participating in bonding. Now see, you know that to form a bond, you know, the army persons, when they, let's suppose we are talking about Indian Army. If Indian Army is going to fight with someone else, with any other country, then first they have to form a group. They will become like same, identical. They will put some color. Their uniform is same. They have particular type of uniform. They will put some color on their faces so that everyone should look like same person. And if any person is having more energy, then definitely that cannot be the part of their group. So to fight is the bonding. Fighting is the bonding. To fight with someone, we have to form a group. Now you can see this p orbital, that is not the part of the group. It is having more energy, and its two lobes are with more energy. So that cannot be the part of the group. Let me show you, kids. Let me show you. So what I want to tell you, my dear friends, if I say this is one carbon, this is another one carbon, and if I draw, it's one orbital, that is sp2, another one orbital, that is sp2, one more orbital sp2. Can you see these are being sp2 orbitals? 3 sp2 orbitals. And the one which is not the part of the hybridization, that is having more energy, that is going above the plane and below the plane. Can you see, kids? This is going above the plane and below the plane. Now its electron is moving very fast. Now the another carbon, I will draw this carbon also, one sp2, another one sp2, the third one sp2. Can you see the 3 sp2? These are 3 sp2, my dear friends. And this is also having one pure P, which is not the part of group, not hybridized, so that cannot participate in sigma bond, that cannot form sigma bond. Now see kids, let me fill the electrons, one electron in this, one electron in this, one electron in this, and if I talk about this one electron in this, one electron in this, and one electron in this. This one will be known as what? Carbon to carbon, sp2 to sp2 sigma covalent bond. This is one type of sp2 to sp2 carbon to carbon sigma covalent bond. Now if I say this one is, these four covalent bonds are being same. Can you see kids? These four covalent bonds are being same. They will be known as what? They will be known as carbon, and this is hydrogen. This was carbon to hydrogen, sp2 to s sigma covalent bond. Now my dear friends, this bonding will be known as what? This bonding, just see, the bonding between this sidewise overlapping, this is sidewise overlapping, just see, sidewise overlapping above the plane and below the plane, above and below the plane is known as pi bond. This is one pi bond. It has nothing to do with the shape. I will draw the shape, but first of all, do let me know this compound. This is ethylene. If I say ethylene is like this, so ethylene is having how many covalent bonds? 1, 2, 3, 4, 5, 6. Out of 6, 5 sigma plus 1 pi bond. Are you getting my point? There are 6 bonds. 1, 2, 3, 4, 5 sigma, 1 covalent bond. Till now, is it clear? Just do let me know in the chat section. Till now, is it clear or not, kids? If yes, show me some fire in the chat section that yes sir, this much is clear. 5 sigma 1 pi bond. I want to see some fire in the chat section, kids. Smash the like button. If you're new to this channel, subscribe our channel. This is the best channel, India's or the world's best channel in English, my dear friends. Now, let me show you the same thing happens in benzene. Let me show you the structure of benzene. Just see everyone. If I say that I am provided with carbons, 1 bond, 1, 2, 3, 4, 5 and 6. 6 carbons. Just see, 1 carbon, 2 carbon, 3rd, 4th, 5th, 6 carbon. All they are being sp2 hybridized. So I will draw like this: 1 sp2 orbital, 2nd sp2 orbital, 3rd sp2 orbital. 1 sp2, 2nd sp2, 3rd sp2, 1 sp2, 2nd sp2, 3rd sp2, 1, 2, 3rd sp2, 1, 2, 3rd sp2, 1, 2, 3rd sp2. Just see, all 3 are sp2. Now if I draw the p orbital, pure p orbital, which is not the part of hybridization, 1, 2, 3, 4, 5 and 6. These are 6 pure p orbitals. Now see, I would like to say one hydrogen, second hydrogen, third hydrogen, fourth hydrogen, fifth hydrogen, sixth hydrogen. Just try to understand, kids, what type of designation I am going to give you, because number of papers they will ask question in the examination. Everyone just see to it. I will say that this is carbon to carbon, sp2 to sp2 sigma covalent bond. And how many such type of bonding are there? One, they will ask designation, 1, 2, 3, head-on overlapping, can you see? 4, 5 and 6. So if anyone is asking carbon to carbon, sp2 to sp2, how many sigma covalent bonds we are having? So the answer will be 6. These are 6 in number. Now if anyone is asking this is carbon and this is hydrogen, if I talk about this type of bonding, this is what type of sigma covalent bond? Carbon to hydrogen, sp2 to s. These are also 6 in number. 1, 2, can you see? 2, third, fourth, fifth and sixth. So you got 12 sigma covalent bonds in benzene. 12, 6 and 6. 6 of one type, 6 of another type. So till now you got total 6 plus 6, 12 sigma covalent bonds in benzene. Now what are these? These will be known as, let me draw these on another page, but till now everything is clear. I will draw the pi bonds, but how to draw the pi bonds I will let you know. But till now everything is clear, kids. Do let me know in the chat section. So I'm going to draw pi bonds. Just see to it. I will draw pi bonds separately. Just see. Just see. Now if I say only I am showing the pi bonds, okay, not the sigma bonds. If this is forming pi bond, this is only one pi bond, above the plane, below the plane, above the plane, below the plane, second pi bond and third pi bond, above the plane, below the plane. It's I can draw it like this. One pi bond, second pi bond, third pi bond. If I draw this one, it has option to form pi bond like this, then this will form pi bond with this, and this will form pi bond with this. It will look like this. Get see. Now you can say the pi bonding actually is like this. Above the plane you can see this is above the plane, above the sigma plane, kids, the pi bond above the plane, and the pi bond is also taking place below the plane. You can say below the plane. So I can draw actually benzene like this. that it's the actual structure of benzene. I hope that this is clear to each and everyone. Just do let me know in the chat section that yes, it's clear. I want to see some fire in the chat section if it is clear to each and everyone, my dear students. Then I will tell you alkyne, and then this lecture will be over, kids. Kids, fast. Now the voice is okay. Am I perfectly audible and visible to all of you, kids? Everyone do let me know. Is it fine? किरण जी, अभी हम आपको ट्रिपल बॉन्ड की कहानी बताएंगे. Till that time, do let me know everyone is able to understand or not. I want to see in the chat section. Wow, that's really awesome. Kiran, Sahana, Arushi, Magic Queen, that's really fantastic. Clear, very good, Shubha Lakshmi. Now, only one portion is left, that is of triple bond. Just see the story of triple bond, kids. See, let me tell you about triple bond. If I talk about compound like this, now see, if I try to find out steric number, I will say 1 sigma and 2 pi bonds. In between two atoms, the one is sigma, rest are 2 pi. Either the upper one or the lower one, that doesn't matter. So steric number will come out 2 sigma bonds. That is, hybridization is sp. Now, let me tell you the whole story, how it is coming. This is carbon atomic number 6. 1s2, 2s2, 2p2. The energy is increasing in this way. Let me take out outermost. So 2s2, 2p2, the ground state configuration. This is the ground state, and the excited state, 1 electron will go from here to there. Now this time the 2 orbitals, they will say we are not going to form the group. They will not participate in the hybridized formation state. These two will not combine, only these two will combine. And if they are combining, then I will say 1 sapota and 1 pineapple. So this one is sp and this is also sp. I am HSP, they are sp. Then 2 orbitals which are not forming the group, they will not be the part of hybridization. Only this is hybridized form, that is not hybridized form. So if I draw on carbon, so if I say this is 1 carbon, so 1 sp hybridized, 1 sp hybridized. Now this is having 1 electron, my dear friend, that is also having 1 electron. Now 2 orbitals which are not the part of hybridization, this is 1 already I have drawn like earlier in the sp2. This has not given its support to form the group, so it is unhybridized. So let me say it is 2py or 2pz, whatever you want to say, you can say. Now the another one that is not the part, it will be perpendicular to that. Both are perpendicular to each other. Now how they will look like, I will show you, kids. I will show you the representation. I will show you how they will look like, my dear students. I will show you in the 3D also, so that we can clearly understand each and everything. So whenever it is coming, you can understand, because these are the basics. Without understanding these basics, we can't do anything. Now see, kids, if I say this is carbon and 1 orbital is going above the plane and below the plane, then the another p orbital should be like this. Let me take one more pen from anywhere, if I can get. Okay, just wait for a second. If I say this is sp, Now this one is going up. Okay, red one is going. So let me take this SP and this is going perpendicular to the plane. Can you see, kids? It is going perpendicular to the plane. Is it visible to all of you? This is lying in the plane, the white one is lying in the plane, and this p orbitals, one lobe is going above the plane, another lobe is going down the plane 90 degree. Can you see? Is it visible to all of you? Yes. Now another p orbital, this orange color one, this is going like this, perpendicular to both. Perpendicular means 90 degree to this and 90 degree to this also. Can you see, kids? Everyone, show me some fire in the chat section if it is clear to each and everyone. If it is clear to each and everyone, show me some fire in the chat section. It is like this. So this is the story of one carbon, and the same story I will say will be of another carbon. This one, you can say this one, and this one is like over here. You can say it's like this, kids. And another one is like this, kids. You can see very clearly now how they are going to form the bond. That I will show you, kids. Let me draw it. Now see, you can see very clearly that this is SP and SP, carbon to carbon sigma bond. Can you see, kids? One. This is carbon to hydrogen, hydrogen to carbon, SP to S sigma bond, and the same is this. Now the pi bonds, the two pi bonds will be like this. One pi bond above the plane, below the plane, and another pi bond, kids, like this, horizontal. Can you see, kids? Can you see? The structure of acetylene is like this. If this structure is clear, show me some fire in the chat section. I want to see some fire in the chat section. If it is clear to each and everyone, kids, do let me know. Am I able to tell you each and everything very clearly, kids? Do let me know, everyone. If the structures are very much clear, kids, I want to see your response. Everyone, do let me know, my dear students. I want to see, kids, whether you are able to understand or not. So this is all about today's class, and my dear students, do let me know everyone is able to understand or not. So today my focus was on type of hybridization. So at the last, I would like to say, just try to find out the hybridization in this compound. See, kids, CH3, CH, double bond CH, C, triple bond C, CH2, CH3. If you are able to understand each and everything, my dear students, do let me know what is the hybridization of this carbon. Yes, do let me know what is the hybridization. So everyone tell me the hybridization. For me, my answer is sp3, sp2, sp2, sp, sp, sp2 and sp3. How many of you are agreed for the answer? Just to let me know how many of you are agreed for the answer, kids. Then I will give you another compound. Once you just to let me know how many of you are agreed with the answer. If yes, show me some fire in the chat section, kids. Let me check it out. How many of you are able to understand that for the first compound your answer is getting matched with what Baba has written. SP3, SP2, SP2. Very good. Now the second one. Everyone just to let me know what is the hybridization of second one, kids. I want to see the second one. Okay. Now, my dear friends, if you are really enjoying this lecture, then I will tell you how to find out sigma bonds. But first of all, tell me the answer. I'm going with SP2 for this. Everyone just check it out. I will say this is SP2, SP2, SP3, SP, SP, SP3, SP3. Agreed or not? Everyone just to let me know. Agreed with my answer or not? Are you agreed with my answer or not, my dear students? If yes, show me some fire in the chat section, then I will give you one question. Baba will give you one question if you are agreed, kids. And if you are really enjoying, how many of you want to do questions, some questions based on this? If you want to deal with some questions, show me some green hearts along with fire, then I will ask some questions and we will deal with some questions. I am waiting for your response. Kiran Pathak is saying, Bilkul Baba, Yamuna Sutha, Kiran Pathak, Sahana. These kids are saying yes. Everyone do let me know. Then I will deal with some questions. So let's see. I'm going to give you one question. Just see. Question is, calculate total number of sigma bonds in phenolphthalein. Phenolphthalein is an acid-base indicator. An acid-base indicator. It is an acid-base indicator, kids. Now you will say, sir, we don't know what is the shape of phenolphthalein, how to do it. Okay, don't worry. Baba will help you, kids. Don't worry. No worries, because I'm going to help you. Let me draw the shape of phenolphthalein. I hope this is visible to each and everyone. Is it visible to each and everyone? Now find out number of sigma covalent bonds. Let's see who is going to. Oh my God, Sahana has written the answer. Others are just trying. Sahana has written the answer. Sahana has written the answer. Kids, you are just waiting. Sahana has typed the answer. Neha Burman is going for 29. I don't know who is going to be. Who is going to give the correct answer, kids? That I don't know. That I don't know who is going to give the correct answer. But yeah, two people, they have shown the answer. Two people's Yeah, they have shown the answer. Now let me check it out whose answer is going to be correct. Now see kids, to find out the answer of this question, we should understand, see kids, what? That this is benzene. You can write it like this, or you can write it like this. The one is resonating structure of benzene and one is being benzene. This is benzene and this is the resonating structure of benzene, right kids? Now if you say that how many sigma bonds this is having, just try to find it out. Once you know benzene, then only you can find out the answer. Now see kids, everyone, I will say 1, 2, 3, 4, 5, 6. These are 6. Now 7, 8, 9, 10, 11, 12. 12 sigma covalent bonds and 3 pi bonds, but we are not interested in these pi bonds. So when one benzene is having 6 plus 6, 12 sigma covalent bonds, right? 12 sigma bonds. Now once again let me go to the structure. This was the given structure, my dear friends, right? Just see, this was provided to you. Now see, my dear students, if I say this is 12 sigma, 12 sigma, 12 sigma. So can you see 12 3 36 sigma bonds. Till now we have got 36. This is 37, 38, 39, 40 and 41. So congratulations. First answer given by Sahana is the correct answer, 41 sigma bonds. Congratulations. Huge round of applause to Sahana. Sahana has given absolutely correct answer. So should I give you one more question? Everyone, do let me know if you want one more question from my side. If you want one more question, just do let me know, kids. If you are really enjoying it, if you want one more question. Everyone, just do let me know if you want one more question. So this was the answer, that this phenolphthalein is having 41, see the 41 sigma bonds. Can you see, kids? Everyone, just to let me know. Now let me check it out. You want one more question? So I have given that pose, Sahana. So right, kids. Okay. That's fantastic. So Baba is going to provide you one more question. Just see, kids. So let me draw one compound. Compound is acetanilide. Name of compound is acetanilide. Acetanilide, kids. Acetanilide. How it will look like? Acetanilide. Its shape is like this. NHCO CH3. Now the question is total number of covalent bonds. Find out total number of covalent bonds. This is your question, my dear students. Find out total number of covalent bonds in acetanilide. Let me check out in the chat who is going to give the correct answer, kids. Everyone. Baba is waiting for your answer. Let's see. HSP. Wow, Kiran. Thank you. Now everyone just let me know what's your answer. I want to see your answer in the chat section. SKS Tamil. Sahana is going with 323. Let me check it out whether Sahana's answer is correct or incorrect. Okay, kids. Some people are saying 28 also. So 23 or 28. 24 also. Some people are going for 24 also. So I have to find out which answer is correct. 23, 24, 28. Once check it out, kids, everyone. Once check it out. Everyone just check it out. So let me see from my side what answer is going to be correct. So I will say up to this benzene 12 and 3 pi bonds, 12 sigma and 3 pi bonds, that is coming out 15 covalent bonds. Now let me check it out for NH C double bond O CH3. So 15, 16, 17, 18, 19, 20, 21, 22, 23. Wow! So those who got 23, that is absolutely correct answer. 23 is the correct answer, kids. 23 is the correct answer. Congratulations to all of you, those who have got 23. So I am going to give you the last question. Last question. Everyone agreed for the last question? Do let me know, everyone. This is going to be a last question for today. Baba has told you about alkane, alkene, alkyne. But before giving you a question, let me tell you something, kids. Let me tell you something, some data I want to share. That I want to tell you, if I draw a line like this, see, kids, one line like this, one line like this, another line like this. Can you see the length? This is lengthier, right? So what I'm trying to tell you, this carbon, and I want to say one hydrogen, another hydrogen, third hydrogen, one more hydrogen, the third hydrogen. Here I would like to say 2 hydrogens. I will draw right now 2 hydrogens. And here I would like to say only one hydrogen. What I am trying to tell you, kids, see. So I will say this bond length is 1.54 angstrom. 1.54 angstrom. This is 1.34 angstrom. Now what is this? What actually these things are? Hydrogen, 1.54. This carbon's hybridization is sp3. All these things definitely will play very, very important role. and electronegativity will be 2.5. 2.5 will be the electronegativity. Remember that. Now, this carbon, okay, let me draw it out. Carbon, double bond carbon. This is hydrogen, 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 hydrogen. The hybridization is sp2, sp2. Now, the electronegativity is 2.75. Here, carbon, carbon, hydrogen, hydrogen, triple bond. The hybridization is sp, sp, and the electronegativity is 3.25. My dear friends, is it visible to all of you? Is it visible to all of you? I think it is visible, my dear friends. It is clear. If it is clear, let me tell you, my dear friends, this carbon's electronegativity is just 2.5. sp2 hybridized carbon's electronegativity is 2.75, but carbon is sp hybridized. Its electronegativity becomes more than that of nitrogen. This electronegativity becomes more than that of nitrogen. So it's all the electronegativity of central metal atom. So percentage of S character increases. If percentage of S character increases, then I would like to say the electronegativity of central atom increases, and then I would like to say bond angle increases. So bond angle, just let's focus on the bond angle also, my dear students. Its bond angle is 109 degree, that is being tetrahedral, tetrahedral, my dear students. This is 120 degree bond angle, so it is trigonal planar, trigonal planar, my dear students, and this is being 180 degree, so it is being linear, 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 linear. I hope that this much is clear to each and everyone. Just do let me know in the chat section. This is all for today, kids. If everyone is able to understand, my dear students, just to let me know in the chat section. I hope this much is clear to each and everyone, my dear students. Everyone, do let me know that this point is clear to each and everyone. वेरी गुड. किरण पाठक जी, आपको समझ में आ गया? सबको समझ में आ गया बेटा? मुझे बताओ, सबको आ गया कि नहीं? जस्ट टू लेट मी नो. थैंक यू, थैंक यू. सो किड्स, this is all for today. If you really liked it, if you have understood today's lecture, first of all, do let me know, did you understand it? If yes, if your answer is yes, then everyone, I want to see in the comment section, not the chat section, comment section, I want to see your comments that how frequently you need such type of classes starting from the scratch, chemistry untold, chemistry untouched, chemistry from the scratch, the chemistry which really holds a hell lot of weightage, but because we are not having that much of time, so most of the time we are going to skip these portions, or we are not going to start with all these things. But my dear students, this is the beginning, and this is the thing from where we are supposed to start. This is the thing which really holds a whole lot of weightage, that everyone, I'll be waiting for your comments, right? So according to that, I will plan out for your next classes. Bye to all of you. God bless you. Love you, kids. Bye, kids.